Hello everyone, a very good day to all of you. Welcome you all to Energy Conversion 2 class, and we are doing with chapter 2 Alternator. Today's topic to be discussed is Alternator EMF equation. So contents for today's topic are Introduction to EMF of an alternator. Secondly, derive EMF equation of the alternator. So introduction to EMF of an alternator. An alternator or AC generator, or we can say dynamo, is a device which converts mechanical energy into electrical energy, obviously. When we supply the magnetizing current by an external DC shunt generator through two slip rings, or we can say in recent alternators they are using electronic starting system instead of slip rings and commutator because the field magnets are rotating. So we can say by an external DC source, let's say DC shunt generator, we are providing the magnetic current. We are giving the supply because the field magnets are rotating. After getting the supply only, the field magnets will start rotating. Keep in mind that most of the alternators are rotating magnetic field with a stationary armature. As we have already discussed, the same alternator can be of two types constructionally, either rotating magnetic field stationary armature or stationary magnetic field with a rotating armature. But most of the alternators are of rotating magnetic field with a stationary armature type. When the rotor rotates, the stator conductors, which are static in case of alternator, they cut by magnetic flux. They have induced EMF produced in them. Why? According to Faraday's law of electromagnetic induction, which states that if a conductor or coil links with any changing flux, there must be an induced EMF in it. So, according to Faraday's law of induction, electromagnetic induction, if there is a conductor and that links with a coil, with change in either of the coil or the conductor, there will be induced EMF generated in it. So now coming to the derivation of the EMF equation of the alternator. Let's P is the number of poles. This is capital P, students. Z, again capital Z, is number of conductors or coil sides in series or phase. That is Z equal to 2T, where T is the number of coils or turns per phase. Okay, note that one turn or coil has two ends or two sides. So T is the number of turn, Z is the total number of conductors. The formula will be Z equal to T. Small f is the frequency of induced EMF in Hertz. Phi is the flux per pole and the unit is Weber. Capital N is the rotor speed, is the speed of the generator we can say, and it is in RPM. Now we know KD, the distribution factor is sin m beta by 2 by m sin beta by 2, and the pitch factor Kc or Kp we can say is equal to cos alpha by 2. If the induced EMF is assumed sinusoidal, of course for AC generator here we have a sinusoidal EMF. So the form factor Kf for sinusoidal wave will be 1.11. This is fixed. Now see, in one revolution, the conductor or the rotor, that is in 60 by n seconds. Okay, in one evolution, that is 60 by n seconds, each conductor is cut by a flux of pi into p webers. Total flux, total number of pole. This will be the flux. Now, d phi will be pi p, and also dt will be 60 by n seconds. So, we can say the induced EMF per conductor. Again, this is the average induced EMF per conductor will be d phi by dt, or we can say d phi ke jagah phi into p. Instead of dt, you can write 60 by n, that is phi n p by 60. This is the average induced EMF. But we know n equal to 120 F by P, or we can say F equal to Pn by 120. Putting this value of n 120 F by P in equation 1, we get the average value of EMF per conductor will be pi P by 60 into n. Instead of n, we have to write 120 F by P. That is nothing but 2 into F pi volt. Now, if there are Z number of conductors in series per phase, then average EMF per phase will be 2 F pi Z volts. Or we can say, if we will write the formula Z equal to 2T, here we will get the average EMF becomes 4 F pi T volts. Now, also we know that the form factor equals RMS value by the average value, or the RMS value we have to calculate finally. That will be form factor into average value. Form factor for sinusoidal wave we know 1.11. Average value of the induced EMF we have already calculated. So now only we will put the values and get the answer. That is form factor 1.11 into 4 F pi T. That becomes 4.44 F pi T volts. Now, the actual available voltage per phase will be 4 kc kt F pi T, or we can say 4 kf kc kd F pi T. Okay, where kf is the form factor. So accordingly we can take the formulas. If kf we don't need to write, we will write 4.ff kc kd F pi T volts. Note down, if alternator or the AC generator is star connected, as usually the case we have discussed for several times, usually, or we can say generally, the most of the AC generators are of star connected for better reliability and better performance purpose. Then the line voltage is √3 times the phase voltage as derived from the above formula. Note down, this is the voltage per phase value, that is known as phase voltage value. But if we have to calculate, we are asked to calculate the line values, then the formula will be √3 times the phase voltage. Why? Because in star connection, we know the relationship between phase voltage and line voltage is VL equals √3 into VPH. Or we can say VPH equal to VL by √3. So, If we are asked VPH, we will simply do the formula. If we are asked line voltage, we will multiply that VPH by √3 only. Thank you all.